The universe is a place of constant movement, never truly still or static. Inside our Milky Way, billions of stars orbit a massive galactic center in a grand dance. Our Sun is one of these stars, maintaining a steady path through the vast cosmic neighborhood. It sits about 30,000 light-years away from the center, following a very consistent trajectory. Every single orbit takes the Sun roughly 230 million years to complete its journey. However, this celestial motion isn't as orderly as it might seem from a distance.
Imagine a skating rink filled with chaotic toddlers, all moving at different speeds and directions.
This cosmic chaos makes the galaxy a dangerous place for any civilization trying to survive. Our local neighborhood is always changing, with stars flying past us at hundreds of kilometers per second. Only the vast distances between these objects keep us safe from the many dangers out there. But in the future, we might run out of luck as cosmic threats draw closer to home. A nearby star-going supernova could devastate our atmosphere and end life as we know it.
Or a massive red dwarf could pass by, showering our planet with a deadly storm of asteroids.
We might see these disasters coming millions of years in advance, giving us time to prepare.
Even with a warning, there is very little we could do to stop such massive events. Unless we find a way to move our entire solar system out of harm's way entirely. Even with a warning, there is very little we could do to stop such massive events. This is the kind of technology an advanced civilization might build to ensure their long-term survival. It requires the power of a Dyson sphere, capturing nearly all the energy a star produces. But how do we move the hundreds of thousands of objects that make up our system? The good news is that we only need to move the Sun itself to succeed. Everything else is glued to it by gravity and will follow wherever the Sun goes. There are many ideas for what a stellar engine might look like and how it works. We have chosen two designs that are grounded in our current understanding of real physics. The simplest design is the Shkadov Thruster, which is essentially just a giant cosmic mirror. It works on the same principle as a rocket, using light particles for momentum. The photons released as solar radiation carry a tiny amount of momentum with them.
If an astronaut turned on a flashlight in space, it would push them backward very slowly.
The Sun produces a staggering number of photons every second, providing a lot of potential thrust. The Shkadov Thruster reflects half of this radiation to create thrust and move the Sun. This slowly pushes the Sun in the desired direction, taking the entire system with it. Gravity tries to pull the mirror in, but radiation pressure keeps it propped up safely. The mirror must be extremely light, made of foil thinner than a human blood cell. A parabolic shape is best, as it maximizes thrust while avoiding overheating the Sun. The mirror must be extremely light, made of foil thinner than a human blood cell. This limits our travel options, but it is a relatively simple megastructure to build.
But if we need to move faster, we might need something much more powerful.
Introducing the Kaplan Thruster,
a high-speed stellar engine powered by nuclear fusion.
It works like a traditional rocket, shooting exhaust one way to push the star in the other. It gathers matter directly from the sun to power its massive fusion reactors. It expels particles at incredible speeds, providing the thrust needed to move a star. A second jet pushes the sun along, acting as a cosmic tugboat for our star. The engine uses massive electromagnetic fields to collect fuel from the solar wind.
Sunlight is focused to heat the sun's surface, lifting billions of tons of matter for fuel.
Helium is burned in fusion reactors, creating a primary source of propulsion for the engine.
A jet of radioactive oxygen at nearly 1 billion degrees becomes our main source of power. To keep from crashing into the sun, the engine must carefully balance its own thrust. Hydrogen is accelerated and shot back at the sun to transfer the engine's thrust.
In just 1 million years, this engine could move the sun 50 light-years away.
This is more than enough speed to dodge a supernova or any other cosmic threat.
But won't we use up the sun if we keep taking its matter for fuel? The sun is so massive that billions of tons of fuel will hardly make a difference.
In fact, removing mass might actually extend the sun's life by billions of years.
We could turn our entire solar system into a massive spaceship for galactic travel.
We could colonize hundreds of other stars as we pass them in our journey.
It might even be possible to escape our galaxy entirely and explore the universe beyond. Stellar engines are machines built by civilizations that think in terms of eons. They allow our descendants to thrive, long after our own star has begun to fade. Until we build a stellar engine, we are at the mercy of the galactic sea.
But maybe one day, our descendants will set sail and become an interstellar species.
Moving through the darkness for millions of years to come, finding new homes in space.
Thank you for watching and for joining us on this long journey through time.